Hi, I'm Ashok. In this video, we are going to cover the third part of number system where we are going to cover LCM and HCF as well as some problems. So let us start with LCM. So the name itself indicates least common multiples. So here we are going to deal with multiples. Multiples in the sense, let us take, if I take the number 3, what will be the multiples of 3? 3, 6, 9, 12 and so on. So the numbers which are divisible by the given number, we are going to call them as multiples. For example, 6 is divisible by 3, 9 is divisible by 3. So these all numbers will become multiples of 3. So let us take an example. I want to find out LCM of 6, 8 and 12. So as we are dealing with multiples, write the multiples of each and every number. So 6, 12, 18, 24, 30, 36, 42, 48 and so on. Similarly for 8. What are the numbers which are divisible by 8? 8, 16, 24, 32, 40, 48 and so on. What are the multiples of 12? The numbers which are divisible by 12 like 12, 24, 36, 48 and so on. Now we are done with multiples. Then least common multiples. After multiple, identify the common ones. What are the common multiples here? Common multiples are, you may find different if you go on further, but till now we are having only two common multiples. Done. Out of the common multiples, find out the least one. Least one means what is the smallest number out of the common multiples here, as you can see. So here 24. Out of the two common multiples we are seeing here, the least one is 24. So the LCM of 6, 8, 12 are 24. So what we are doing here, we are dealing with multiples. After writing multiples, we are finding out common multiples. After finding out common multiples, we are selecting the least one among them. So that's why we are going to call it as LCM, least common multiple. Now, what is the use of this LCM? The smallest number which is divisible by all the given numbers, like 24 is the smallest number which is divisible by 6 as well as 8 as well as 12. So LCM is going to give you the smallest number which is divisible by all the given numbers. Okay, this is one way of finding out LCM. Like you are going to write multiples for each and every number, then you are going to find out common multiples, then you are going to identify the least one. But the problem here is, if the number is somewhat bigger, like 123, 146 and so on, writing multiples like this is somewhat difficult. That's why we are moving on to the next method, that is prime factorization. Like prime factorization in the sense, I am going to take the same example, 6, 8 and 12. Write these numbers as multiples of prime numbers. Like 6 can be written as 2 into 3. Both of them are prime numbers. 8 can be written as 2 into 4. But 4 is not a prime number. Further divide this one as 2 into 2. Then what about 12? 12 can be written as 2 into 6. But 6 is not a prime number, so 2 into 2 into 3. Write like this. Write every number as a product of prime numbers. That is the first step. Then, in the second step, try to identify what are the numbers you are seeing here. I am seeing 2 as well as 3. Now, try to identify the highest powers. Like all the numbers, write it here. Like I can see 2 and 3, 2 and 3, I can see 2. So, write every number you are seeing here. Then identify their highest powers. Like here 2 power 1, 3 power 1. But here 2 power 3. Here 2 square and 3 power 1. So out of all the 3, what is the highest power of 2? 3. That is 2 cube, because here. Then what is the highest power of 3? Here 3 power 1, 3 power 0 and 3 power 1. So again 3 power 1. Write all the numbers with their highest powers. Now multiply these two. 8 into 3. This is going to give you your LCM. What I'm writing? Write each and every number as a multiple of prime numbers. Okay, after writing them as a product of prime numbers, write all the numbers you are saying with their highest powers. Multiply that, you will get your LCM. Again, the drawback with this method here is, if the number is too big, so you are going to get so many terms here, which is somewhat difficult to identify the highest powers. That's why we are going to go to successive division. Successive division means we have been doing from childhood. So we are going to write all the numbers like this. We are going to start with the prime number and we are going to cancel them. For example, Here 2 can be cancelled 3 times, here 4 times, here 6 times. Again, I can cancel 2. If the number is divisible by 2, you are going to write the coefficient. If not, drop the number as it is. Because you can't cancel 2 in 3, so I'm going to write 3 as it is. Here 2 times, here 3 times. Again, 3 is here. 1 time, 2 is not getting cancelled, so 2 drop. Again, 1 time. Multiply everything like this. You have to continue this process until you get all distinct numbers or all ones. So multiply all the left side terms. See, 2 is 4, 4 is 12, 12 is 24. Again, you are going to get the same LCM. So these are the three methods which we are going to use to solve LCM. Like that, now we are going to go for HCF. HCF is highest common factors. So let's deal with factors now. So what are the factors of 6? 1, 2, 3, 6. Okay, the numbers which can divide 6, they're divisible by 6. Here divide 6. So 1 can divide 6, 2 can divide 6, 3 can divide 6, and 6 can also divide 6. So the numbers which can divide 6, we are going to call them as factors. Let us take the same example. Or if you want to make it somewhat difficult, take some other example. For example, I will take 6, I will take 9, I will take 15. I want to find out the HCF of all these three numbers. Now, we are dealing with factors. So write the factors. What are the factors of 6? 1, 2, 3, 6. What are the factors of 9? 1, 3, 9. What are the factors of 15? 1, 3, 5, 15. Done with factors. Now identify the common factors. What are the common factors? Common factors here are 1, 3, 1, 3, 1, 3. Done. Identify the highest factor. What are the highest factor? 3. So that means HCF of 6, 9 and 15 is 3. So what we are doing here, we are going to write factors of each and every number. Then we are going to identify common factors. Then we have to take the highest one. That is the meaning of HCF, highest common factors. That means that 3 is the highest number which can divide all the three given numbers. Like it can divide 6, it can divide 9, it can divide 15. That is the highest number which can divide all the given numbers. Okay, there in LCM it is divisible by, here divides. But the problem here is, if the number is somewhat bigger, we can't write, for example, if I take 120, I can't write all the factors of 120 here. That's why we are moving on to the next method, which is prime factorization. So 6, 9, 15. Write all the given numbers as a product of prime numbers. Here 6 is 2 into 3, 9 as 2 into, it is not possible, so you're going to write 3 into 3, 15 as 3 into 5. All the numbers are prime numbers, so no issue. Now, there you are going to take in LCM all the numbers, but in HCF, you have to take only common numbers in all of them. What are the common numbers? See, 2 is here, but 2 is not there, 2 is not there. So don't take 2. 3 is there, 3 is there, 3 is there. So take 3. 5 is not here, 5 is not here, 5 is there. So don't take 5. Only take the common numbers with their least powers. Here 3 power 1, here 3 square, here 3 power 1. What is the least power? 3. So simply that is going to give you the HCF of the given numbers. If you got 2, 3 common numbers, you just need to multiply them like we did in LCM. Here also the same thing. But remember, write all the common numbers with their least powers. That will give you the value of HCF. Now, you will get some problems on HCF. You can use these rules to solve those problems. I will show you one example. So as you can see here, see, the question here is, what is the smallest number that is divisible by 6, 8, 18 and 24 and 36? So see here, we want to find out the smallest number which is divisible by all the given numbers. Go back to your formats. Here you can see some formats. See here we are dealing with the least number. See, the least number which is divisible by all the given numbers. So the answer is going to be LCM of the given numbers. You have to apply the same logic there. See, we are finding out least number which is divisible by some numbers. There you are going to find out LCM of those numbers. So here also you are going to find out LCM of 6, 8, 18, 24 and 36. That is going to be your answer. I hope you know how to find out LCM, so I don't want to drag it. So that's what you are going to do here. Similarly, don't worry, I'm going to solve all these problems once again. Now see, He is asking what is the largest number which can divides all these numbers. The largest number that can exactly divide all the given numbers. Go back to your formats. See, the greatest number that will exactly divides the given numbers. Nothing but HCF of all the given numbers. So here also we are going to do HCF of 52, 65 and 143, like that. Okay, so these are the format. Now before moving on to the problem, there is one more way of solving HCF. That is, see, here if you are having very large number like 130 and all, writing prime factorization is somewhat difficult. That's why we are going to do successive division here. Successive division means let us take, we want to find out HCF of 6, 9 and 15. Take any two numbers of your choice and divide one number with other number. For example, what is 166? 6. You are going to get the remainder as 0. If you got the remainder here itself as 0, the last divisor is going to be your answer. But here we are not getting 0 as remainder. So you have to repeat the once again. That means make your remainder as your divisor and your previous divisor as dividend and do the process again. You have to continue this process until you get 0. Wherever you are getting 0, the last divisor is going to be your HCF. That means HCF of 6 and 9 here is 3. With the answer to the third one, that is 3, 15. 5 3s are 15. You are getting 0 here itself. No need to go further. So the last divisor, that is 3, is going to be your final HCF. So the HCF of 6, 9 and 15 is 3. What we are doing here, take two numbers, divide one number with other. Okay, if you're getting remainder as 0 here, the last divisor is going to be your answer. If you are not getting the remainder as 0, continue the process by making your remainder as divisor and previous divisor as your dividend. Okay, continue this process until you get a 0. Wherever you got 0, the last divisor is going to be your answer. So for two numbers we got 3. With this number, do the third one to find out your final HCF. Here I am getting 0 in the first step itself, so no need to do anything. My final HCF is going to be 3. Like, I will solve one more problem here, like the previous question. Let us take here, I want to find out HCF of 52, 65 and 143. So I'm going to take only two numbers. So 152 is 52, 3 and 1. I didn't get the 0, so I have to go further. 52. 4 3s are 12. Let us take 4 times. So 4 3s are 12, 4 1s are 5. So here I got 0 here itself. So wherever you got 0, the last step is going to be your HCF. So here for these two numbers, HCF equal to 13. With that answer, do the third one. 113 is 13, 113 is 13. So here got 0. So nothing to remind us. So here the last divisor is going to be your answer. That is also 13. Okay. So wherever you got here, the HCF of all the three numbers equal to 13. That's it. You have to take two numbers, do like that until you get 0. Or if you are feeling this is confused, write like this. 13, 143. I got 11 times as 143. So 0 here itself. So the last divisor is going to be my 13. So that is my HCF for all the given three numbers. Take any two numbers, find out the HCF. With that answer, find out the third one. That's it. That is how you are going to calculate your HCF. Okay. So the answer here is 13. Okay. So like that, we are having different formats. For example, find the greatest number that will divide x, y, z, leaving a, b, c as remainder. For example, let us take, if we are dividing with 5, the remainder is 2. Okay. If you're dividing with 7, the remainder is 3. If the remainder is 8, the remainder is 1. Then what is the greatest number that will give you that kind of answer? Then this will become x, y, z, and these will become a, b, c. Apply this format. Okay, here, sorry, which one is, yeah, this one. This format, x minus a, y minus b, and z minus c. Find out the HCF of these numbers that will give you our answer. The greatest number that is dividing different numbers, leaving the reminders, different reminders, a, b, c. So these are the most used and common formats in LCM and HCF. The first three are related to HCF and the next three are related to LCM. Okay, so look at them once, take a screenshot of them, try to remember what kind of formats you are having. We'll solve all those problems later on. Okay, now let's move on. All of you, please make sure of all these formats. Okay, let's solve some problems, then we will wind up the session. See, here the problems are, what is the smallest number that should be added to this one to make it divisible by 9? So here we can use divisibility rules. What is the rule of 9 here? Sum of the digits should be divisible by 9. So add all of them. 9 plus 8, 17, 17 plus 3, 20, 25 and 32. Here I got the sum as 32, but 32 is not divisible by 9. So in order to make it divisible by 9, I have to add 4 more, which will make it 36, so I can cancel 9. So the least number which I added to this number to make it divisible by 9 is 4. That's it. We know the divisibility rule is sum should be divisible by 9. So after adding all of them, I'm getting only 32. But to make it divisible by 9, I want at least 36. So the least number I have to add here is 4. That's it. Next, what is the smallest digit which should replace x in the number to make it divisible by 12? What is the rule for 12? You have to divisible by both 3 and 4. The rule for 4 here is the last two digits should be divisible by 4. Anyway, we got already a number which is divisible by 4, so there is no use. Let's use the divisible rule of 3. What is the rule of 3? Sum of the digits should be divisible by 3. So 3 plus 5, 8, 8 plus 6, 14, 15, 16, 17. I got 17 plus x. I know this number should be divisible by 3. See here. 3 plus 5, 8. 8 plus 6, 14. 14 plus 3, 17. So if I want to make this number divisible by 3 means x should be at least, okay, 1. Because 6 3s are 18. So the smallest number is 1. Okay. Even if you add 4, even if you add 7, still you will get your answers. But I want the smallest number. That's why I'm saying 1. So here my answer is 1. Next, in order to apply these kind of numbers, you have to learn entire algebra formulas. So I will write few of the formulas here. So try to learn them. It will be helpful to you while simplifying these kind of problems. Okay. So just give me one sec. I will write all the formulas first. So let's go. We'll write all the algebra formulas one by one. Okay, use those formulas to find out your answers. We're going to start with okay, a plus b whole square. So remember all these formulas. Use these formulas to find out your answers. That will make it further simple. Okay. Okay. So similarly, a minus b whole cube is going to be a cube minus 3a square b plus 3ab square minus b cube, or you can also write it as a cube minus b cube minus 3ab into a minus b. Okay. Similarly, a plus b into a minus b is equals to a square minus b square. Next, a cube plus b cube is equal to a plus b into a square minus ab plus b square. Okay, so a cube minus b cube is equal to a minus b into a square plus ab plus b square. Okay, the last and final one, a plus b plus c whole square is equal to a square plus b square plus c square plus 2ab plus 2bc plus 2ca. Okay, try to learn all those formulas so you can use these kind of you can solve these kind of problems. So let's solve it. See, the difference between two numbers is 4. Let us take two numbers are a minus b, that is 4, and difference between their squares is 128. That is a square minus b square equal to 128. What is the largest number? You have to find out the value of a. We know a square minus b square equal to a plus b into a minus b. We know this so this value is equal to 128. In that we know that the difference is 4, that is this value is 4. So a plus b is going to be 128 by 4, that is 32. So we know that a plus b equal to 32 and a minus b equal to 4. B cancel. So 2a is going to be 36. So a is going to be 18. That's it. That's the largest number. You can solve like that. So these are the problems in number system. You can find these kind of only. So the same thing. And one more thing, guys. The product of LCM and HCF will be always equal to product of the numbers. For example, if I am saying 12 and 13, find out LCM, find out HCF. If you multiply those two, again you are going to get them as 12 into 13. So product of LCM and HCF is always equal to product of the numbers. Like if AB are two numbers, the LCM of AB multiplied with HCF of AB will be always equal to A into B. That's what we are going to do in this problem. See here LCM and HCF of two numbers is 330. So LCM is equal to 300 and HCF is equal to 30. If one of the number is divided by 4, the quotient is 15. See, let us take you are having one number as A and other number as B. If you are dividing this number with 4, you are going to get coefficient as 15. That means that A will be equal to the first number 15 into 4, which is equal to 60. You want to find out the other number. So we know that 60 into other number is equal to LCM into HCF. Why? Product of two numbers is always equal to product of LCM and HCF. So product of LCM and HCF equal to product of two numbers. I'm assuming the first number as A and I got this as 60. So here what will happen? This is 5 times. So the second number is equal to 150. That's it. So product of LCM and HCF is equal to product of the two numbers. By using that, you can find out the other number. Okay, that's it for today's class. So we have covered the first one, divisibility rules. Then we covered power cycle. Then we covered remainder cycle. Then we have done problems on LCM and HCF. Then we have done problems on number system. That's it. I hope this one is clear. If you are having any doubt, please let me know in the comments. Thank you.